In last video, we discussed about the packing efficiency of body-centered cubic cell. In this video, we are going to discuss relationship between molar mass, density, and unit cell edge length. Now consider the edge of unit cell A. Then the volume of unit cell, it will be A cube. Suppose the mass of one atom m, small m, and the number of atoms or particles present in unit cell, it is given by Z. For a simple cubic cell, value of this Z is 1. For body centered cubic unit cell, it is 2, and for face centered cubic cell, it is 4. That is, in simple cubic cell, 1 atom is present. In body centered unit cell, 2 atoms are present, and in face centered cubic cell there are 4 atoms. Now the mass of unit cell, it is equal to mass of one atom into number of atoms, that is m into z. So this is the mass of unit cell, m into z. Now the density of unit cell, it is equal to, or it is given by rho, it is equal to mass of unit cell upon volume of unit cell. Actually, density, formula for density is mass upon volume, and therefore density of unit cell, it is equal to mass of unit cell upon volume of unit cell. But mass of unit cell, it is m into z, and volume of unit cell, it is a cube, and therefore density of unit cell, that is rho, it is equal to m into z upon a cube. But we know that mass of one atom or one particle, we can find out from molar mass and Avogadro number. So mass of one particle or mass of one atom, it is equal to molar mass of substance upon Avogadro number. That is, m is equal to molar mass upon Na. Now substituting the value of this m, that is mass of one particle, this m, in this equation number 1. So this m, it can be substituted by capital M, that is molar mass upon Na. So substituting value of mass of one particle in equation 1, then we get this rho, it is equal to m upon Na. M upon Na, this is for small m, that is mass of one particle. So rho is equal to m into z upon a cube into Na, where rho, it is the density, capital M, this is the molar mass, z is number of particles present in unit cell, a cube, it is the volume of unit cell, and Na, this is the Avogadro number. This relation is very important. Now we'll solve some examples on this relation, and already I told you that Z for simple cubic cell, it is 1, for body centered cubic cell, it is 2, and for face centered cubic cell, Z is equal to 4. Now first example is lead has face centered cubic cell structure with edge length of unit cell equal to 495 picometer. What is the radius of lead atom? What is the given? Lead element is there, it has a face centered cubic structure, edge length is given 495 picometer, and we are going to find out the radius, that is r. For face centered cubic cell, we know the relation between edge length and radius. A is equal to 4r upon root 2, or r is equal to a upon 2 into root 2. So we know, actually first of all find out the 1 upon 2 into root 2, this is equal to 0.3535. So 0.3535 into a, so just r is equal to 0.3535 into a. Now we know the value of a, that is 495 picometer. So it is equal to 0.3535 into 495 picometer. This is in picometer. So it is equal to 175 picometer, and therefore radius of lead atom, it is 175 picometer. Another example, the density of iridium, it is 22.4 gram per cubic centimeter. The unit cell of iridium is face centered cubic cell. Calculate radius of iridium atom. Molar mass of iridium is given, it is 192.2 gram per mole. Now what is given? Element is iridium, it has a face centered cubic structure. Its density is given 22.4 gram per cubic centimeter. Find out R. Molar mass is given 192.2. Number of atoms in face centered cubic cell, it is known, that is 4. So Z is equal to 4. Avogadro number Na, it is 6.023 into 10 raised to 23. Now we know the formula, rho is equal to, that is density is equal to m into Z upon A cube Na. So here rearrange the equation for A cube, that is volume of unit cell. So A cube, it is equal to m into Z upon rho Na. Just this density and A cube, these two terms will be exchanged, and this is the formula for volume of unit cell. Now we know the values of all the terms. Substitute the value. Molar mass of substance is given, or iridium is given 192.2. Value of Z is 4. Density is given 22.4. Value of Avogadro number is also known. When we solve this, it comes 56.98 into 10 raised to minus 24 cubic centimeter. Cubic centimeter. Actually density is given in cubic centimeter, and therefore this volume, it will come in cubic centimeter, and therefore A is equal to, that is edge length, cube root 56.98 into 10 raised to minus 24 centimeter cube. So after solving this, we get 384 into 10 raised to minus 10 centimeter. But 1 picometer, it is equal to 1 into 10 raised to minus 10 centimeter, and therefore this is equal to 384 picometer. Actually 1 picometer equal to 10 raised to minus 10 centimeter. So edge length, this is 384 picometer. Edge length of iridium, it is 384 picometer. Now for face centered cubic structure, radius R, it is equal to A upon 2 into root R is equal to A upon 2 into root 2. We know the value of A now. Actually this can be simplified as, actually 1 upon 2 into root 2, it is equal to 0.3535. So R is equal to 0.3535 into A. Just to substitute the value of A, it is 384 picometer. So when we solve this, then it comes 136 picometer. So radius of iridium atom, it is 136 picometer. Now next problem is aluminium crystallizes in cubic close packed structure with unit cell edge length, it is 353.6 picometer. What is the radius of aluminium atom? Again, what is given? Aluminium element is there, it crystallizes in cubic close packed system or face centered structure. Edge length is given 353.6 picometer, which is equal to 353.6 into 10 raised to minus 10 centimeter, because already I told you 1 picometer, it is equal to 10 raised to minus 10 centimeter. Now number of atoms present in FCC, it is equal to 4. Consider the volume, it is 1 centimeter cube. Radius we have to find out. Okay, Now for face centered cubic system, A is equal to 4r upon root 2, or r is equal to a upon 2 into root 2. So r is equal to 0.3535 into a, because 1 upon 2 into root 2, it is equal to 0.3535 into 3535, and this is the a. So just to substitute the value of a, it is 353.6 picometer. So it is equal to 0.3535 into 353.6 picometer. So answer is 125 picometer. So radius of aluminium, it is 125 picometer. Radius of aluminium, it is 125 picometer. And the last problem, an element with molar mass 27 gram per mole forms cubic unit cell with edge length of 405 picometer. If the density of element is 2.7 gram per cubic centimeter, what is the nature of cubic unit cell, whether it is face centered, body centered, or simple cubic? This is the given. Molar mass is given 27, edge length is 405 picometer, which is equal to 405 into 10 raised to minus 10 centimeter. Density is given, that is 2.7 gram per centimeter cube. You have to find out the nature of unit cell, whether it is face centered, body centered, or simple cubic unit cell. This is the formula: density equal to m into z upon a cube into na. Actually, when we find out the value of z, then we come to know the nature of unit cell. That we know that for a simple cubic system, value of z is 1. For face centered cubic system, value of z is 4, and for BCC it is 2. So just to find out the z, so rearrange the equation for z. We know all the terms. So z is equal to rho, that is density, into a cube into na, that is the Avogadro number, upon m, that is molar mass. Substitute the values. Density is given 2.7. Again, value of a is also given 405 into 10 raised to minus 10 cube. This is for a cube. And Avogadro number is also known, 6.023 into 10 raised to 23 upon 27. This is the molar mass. When we solve this, it comes 4. So z is equal to 4. So as z is equal to 4, the nature of unit cell must be face centered cubic, that is FCC. So in this way, from this given data, we can find out the nature of cubic cell. As z is equal to 4, this unit cell must be face centered cubic.